All right, so we're going to try it again. Here's that function we were working with. F of x equal to the natural log of x plus 1 divided by square root x minus 2. And we're going to keep these log properties in mind. These are going to be helpful. So let's start by trying to actually simplify. Let's simplify this function. Before we start doing any derivatives, let's see if we can simplify this down. So the first thing we can do, if we're looking inside the log function here, is there's division. We have division inside our log function. So what happens with division? Well, if we have a fraction inside our log function, it ends up becoming subtraction. So we're going to have the natural log of x plus 1 minus the natural log of square root x minus 2. So it's the natural log of the top minus the natural log of the bottom. And we're not doing any derivatives here. This is just the log properties. So these are just algebraic properties of the log function. No calculus here. So we're using log property B here. All right. So now we want to see if we can simplify these any further. This first one we're stuck with. The addition inside the log function, we're stuck. We're at a point with this first one that there's nothing more we can do. But there is something we can do with the second one. So the first one we're done with. But this other one, we can rewrite that root function as raised to the power 1/2. So it becomes x minus 2 raised to the power 1/2. And it's this entire thing that's inside the log function here. So it's x minus 2 raised to the power 1/2, and then that whole thing is in the log function. And so what we have here is we have this exponent that's being applied to all the terms inside our log function. And that's our third property. So what's going to happen to this 1/2? Well, we can actually bring it outside of the log function and put it in front. So it becomes negative 1/2 times the natural log of x minus 2. So this 1/2 comes outside the log function, and then it just becomes multiplication. It just becomes a number in front. So it's no longer in the exponent spot. It's just a regular number, kind of on the main line of all of our operations here. It's 1/2 times the natural log of x minus 2. And that is property C, this exponent ones. And we want to look at these log functions, see if there's anything else we can do. But in each of these, we're at the point where there's nothing more. So we have addition here, we have subtraction here. There's no more multiplication or division or exponents. Same thing here. So we're kind of reached our limit. But that's okay. So that means we're just ready to differentiate. So now we're going to differentiate. So all of this was just algebra. We did a lot. But all of this was just algebra. So now we're ready to calculate the derivative. So we start by differentiating this first one. And it's an outer log function and an inner polynomial. So we differentiate our way through the log function first. So it's 1 over what was originally inside. So 1 over x plus 1. And then we multiply that by the derivative of what's inside. So a little bit of a chain rule here. Or general log rule, if we want to call it that. Because it's the special case where our outer function is a log function. So differentiate through the log function gives us 1 over what was inside. And then we multiply by the derivative of the inner function. And then we play the same game over here. So we have a minus 1/2. And we want to differentiate this log function. So again, it's a composite. So we need to differentiate our way through this log function first. So it's 1 over what was inside. So 1 over x minus 2. And then we take that inner function and we multiply it by its derivative. So we're going to multiply by derivative of x minus 2. So this is another chain rule here. And we keep going, and derivative of x plus 1 is 1, and derivative of x minus 2 is 1. So, these derivatives end up just being 1. So what we end up with is our derivative is 1 over x plus 1 minus 1/2 times 1 over x minus 2. And we're done. So that's quite a bit easier. The differentiation process here is quite a bit easier as compared to what we were trying before. So let's go back to what we were looking at before. We were going to do start with chain rule. Then we were going to have to do a quotient rule to kind of differentiate through the fraction. And then we're going to have to do another general power rule to differentiate through the square root. So this thing was going to look pretty complicated. And instead, these log properties really simplified the process. It gave us a kind of a different version of our function, which was a lot easier to differentiate. So we only had to do these kind of easy chain rules here. And why are these properties so helpful? Well, instead of having multiplication, which we know is difficult to differentiate, and instead of having a fraction, which we also know is difficult to differentiate, and even power functions like this, we have a power rule, but it's more complicated to differentiate. The multiplication gets converted into addition, which is a lot easier to do our calculus with. The fraction gets converted into subtraction, which is also a lot easier to work with. And then this exponent ends up becoming multiplication, which in some ways is easier, especially if that's a constant multiplication, then that's no problem at all. So these log properties kind of convert things, or allow us to convert things into addition or subtraction or maybe constant multiplication, which are easier to differentiate. And so this really sets up our new differentiation technique that we're going to look at, called logarithmic differentiation. So this technique, what it's going to allow us to do, it's going to leverage all of these properties to really make, if we have a complicated looking function where there's going to be multiple rules that need to be used, maybe we can use some of these log properties to simplify it down first. So we're going to see that technique next.